Hello everybody, my name is Benji Bengaid. I'm a researcher at IFPN, which is the French National Research Center in Energy and Transportation, and I'm very glad to talk to you about Toolkit that we released in open source in the beginning of this year to help build quickly and easily dashboards for Python code. First, let me talk to you about our project history and motivations. Our project started in 2016 as an internal tool codenamed Xdash. It was originally targeted to allow my colleagues, which were researchers or engineers, to build in an autonomous way interfaces in the form of web applications to allow them share with other colleagues the scientific code they develop. Our original approach was to build a SCADA-like virtual experimentation tool for API. We integrated Python language in 2019, and that was a very important evolution for our tool. To make things clear, let me show you a demo. This dashboard illustrates the real-time bikes availability of the Philip bike sharing system in Paris. It was built with very few lines of Python code using pandas, GeoPandas, Plotly, and our built-in version of Leaflet only in Python. It is an interactive dashboard. I can here do a selection on map, and this produces a GeoJSON that I use for a GeoPandas selection. And this allows the histogram to be updated according to the stations I have here in the map. Okay, let's now dive into the details how such dashboard can be easily made. You can easily install Toolkit using pip and then run it in command line or use the online hosted version in your browser. So let's now dive into the tool. Toolkit is a document-oriented tool. So all your work is stored in a project, which is similar to the IPyNB file format of a Jupyter notebook. The project contains a dashboard, which is built using drag and drop. The dashboard is a set of widgets, and widgets may be connected to data nodes. Data nodes are important in Toolkit. They are similar to the cells of Jupyter notebook. You can see them as Python codes or JavaScript codes that write objects to the workspace that can contain files, text files, binary files, or variables. In this example, the widget writes a value to a variable data node. Application logic is described by a data flow graph of data nodes. So the execution is performed according to data flow rules. And when you build your dashboard with Toolkit, you don't have to care about callbacks. Everything is done automatically. You have only to bind your widgets to your data node. And Toolkit allows to execute the dashboard in an efficient and deterministic way. So with Toolkit, you can add your favorite Python libraries in PyODide using the libraries tab. These are examples of libraries you can use. Widgets can be added using drag and drop, and you can use a rich widget editor, which have multiple selections and do redo alignment, etc. Wide variety of widgets also for input and display, sliders, text, inputs, gauges, maps, etc. You can use your favorite graphing libraries like Plotly, Charts, Vega, Matplolib, etc. What you have to do is to write a data node with Python code or JavaScript code description of your widget, and then connect it to the widget this way. Okay. Dataflow is very simple. It's based on a single keyword, which is called data node, that tells the execution engine to establish Dataflow execution rules. This allows to enable very complex interactions. And when you finish, you can export all your work to HTML file, to standalone HTML file. Okay, what's next? We have a rich and living roadmap that we would like to share with you. I will be glad to meet you at Scipy.